So the study guide is more than just the page and problem numbers. It's telling you what you're supposed to be getting out of that too. Like this one, it'll say, solve the absolute value equation, be able to solve absolute value equations and greater than inequalities. Greater, they should have said greater than absolute value. Yeah, I'm giving one line at a time. At the end, I'll give you the whole thing. Okay, so an absolute value equation. What's the first step? What's always the first step? Starts with an I. Isolate, right? You got to get that absolute value alone, right? So in this problem, what do we have to move? Subtract the 4, right? So subtract 4, subtract 4. So this is absolute value of 2x minus 1 equals 9. Okay, once the absolute value is isolated, for each kind of problem, you got a little bit different step. For an equation, what is the step? (2x minus 1 equals 9), meaning if the 2x minus 1 equals 9, then when you take the absolute value, it's still 9, and you got an equality, right? Or what else could be the possibility here? Yeah, if this equals negative 9, when you take the absolute value, it'll equal positive 9. So we solve these two equations. Okay, so add 1, 2x equals 10, x equals 5. Add 1, 2x equals negative 8, x equals negative 4. So I'm pretty sure this is a multiple choice format of some kind, right? So remember, you have options in terms of like if you got possible answers there, you can just plug them in and see which one works. It's always an option. Okay. So for the greater than absolute value inequality, again, we have to isolate. What do I have to do to this one? Divide by 2. So divide 2, divide 2. So now I've got x plus 3 in absolute value is greater than or equal to 5. Okay, so what is the step now that you take? It's pretty close to the same thing, right? For the greater than, you break it into two different inequalities. What will one of them say? Yeah, either the x plus 3 is greater than or equal to 5, or, so the or is part of the answer, what? Or it's less than or equal to negative 5, because if it is less than or equal to negative 5, when you take the absolute value, it will be greater than or equal to 5, right? Because that's what absolute value symbols do. So it's either that or it's that. That the 5 becomes a negative 5, the greater than or equal to becomes a less than or equal to. Okay, solve them both. Subtract 3. X is greater than or equal to 2. X is less than or equal to negative 8. And there's an or. Okay, what does that look like on a graph? Right? So if the negative 8 is there and the 2 is there, is it open or closed circle? Because it's or equal to, it's closed circle on both of those numbers, right? For x less than or equal to negative 8, which way do I shade? To the left, right? Because the x is representing the shading, right? And if on the number line, less than is always to the left. So we shade this way. And what about the 2? To the right, okay? So greater than on the number line is to the right, so you shade to the right. Right. Or, remember that if you've solved for x on the left, right there, then you could take that inequality symbol like an arrow telling you which way to shade, right? That's telling you shade to the right of 2. It's an arrow pointing right. And that's an arrow pointing left, to the left of -8, right? That works because the x is on the left side of the inequality. It would be exactly the opposite if it wasn't. What other option do you got for that? Could you put it in the calculator? Remember, how do you put it in the calculator? I don't think my calculator's up here. I had it at home. Remember on the calculator, on the y equals, you can put it in up there. The only thing you're going to have to remember is where do you find, well, you don't even have to solve it, right? You could put it in just like this. 2 times absolute value of x plus 3. Where's the absolute value? Clear. Right, 2 times. Where's absolute value in the calculator? Math, arrow over to the num, 1, ABS, right there. There's another way, y equals. You can go alpha, window, and then you could see the very first thing comes up, absolute value. There's one other way you could do this. You could go second, and then go down to the catalog, and catalog is on 0. And it's a list of all the functions in the calculator, and ABS happens to be the very first one. So that actually may be the quickest way to find it, is just go to the catalog. It's the first thing right there. But one way or the other, you get it, right? Oh, clear. Okay, and then inside the absolute value, you put your expression. In our case, it was x plus 3. X plus 3. Right? Then you got to know, where do I find that greater than or equal to symbol? Second math, and there's all the symbols. So I put in the 4 for greater than or equal to, and I put in a 10. Oh, that was wrong. Now I put in a 10. Graph. And you can see there's the 2 into the right, and there's the -8 into the left. Okay, and we didn't even isolate it or anything. It'll do the whole thing for you. Okay, write the equation of a function by looking at the graph. Now we're going to do both. This is what we just did in the homework right there, but it works exactly the same for absolute values. And these are part of what they're calling their common assessment that I'm required to give you, so I did. Okay, so we look at for the vertex. What kind of function is this? Because of the shape of the graph of V, it's absolute value, right? So make sure you choose a function which is actually an absolute value. And then the vertex on this first one is 1, 2, 3, 4, 5. 5 to the right and 1 up, right? So how do I make that parent function of the absolute value of x go 5 to the right? Right? Inside, I say x minus 5, right? And then how do I make it go 1 up? Plus 1 at the end. And how do I make it open down? Put a minus in front. And then the last thing, because you do have stretches and compressions of absolute values too, does this thing look like it's been stretched? I mean, it would be just like the squared function. You would expect on this function that if you put in 1 or -1, you get a value of 1, right? But this is not. This one, I go 1 to the right and I go 2 down, not 1 down. So it's got a 2 in there. So that's the function. How about this one? The vertex is, or the shifts This is shifted 2 to the left and 6 down. How do I show 2 to the left? X plus 2 and 6 down. Okay? Does it need a minus in front of it? No. Has it been stretched or compressed? Does it look like it's going over 1, up 1? It looks like it's going over 1, up 1/2. It's kind of, you can see it's kind of flattened out, kind of. So we put a 1/2 right there. Y equals. Now we just did the 37 and the 35, but we didn't do the 36. Now if you see this shape of the graph, what kind of function? What is the parent function? It's a parabola, so it should be, you know, some kind of a transformation of f of x equals x squared, okay? How do we shift that parabola to go 1 to the left and 3 down? So 1 to the left would be plus 1 inside, remember the squared. 3 down means minus 3. And does it look like it's been stretched? It does kind of look like it's been stretched, right? Because it's not going over 1 and up 1. It's actually going over 1, up 2. If you came up with your function, right, and you're not sure, put it in the calculator, put it on the y equals, and see whether you get back the graph you were trying to approximate with that equation. Okay, describe the transformations and sketch the graph. Actually, I think it just says describe the transformations. It's taking you to those same problems we did in the homework last night, which said graph, but the test question does not say graph. It just says describe the transformations. So let's see. The minus 4 is right. The plus 8 is up. And the 2 is, when you multiply by a constant, it is, it's a stretch. Okay. That's a stretch because it's greater than 1, right? If it's less than 1, you'd call it a compression. Okay. Identify the vertex. Given this vertex form of a quadratic function, identify the vertex, the axis of symmetry of the parabola, and determine whether it represents a maximum or a minimum. And there's a mistake. I'm going to put a minus in front of this one right here. Back to blue. I meant one of them to be plus and one of them to be minus. Okay. Does this parabola open up or down? Because of the minus in front, it means the shape of this graph is going to be like that. Okay. So now the vertex of a parabola is always either the maximum point or the minimum point on the parabola. Which is it when the thing opens down? It's the maximum. It's the highest point on the graph. The y value would have been the maximum y value on the graph. So when you see that it's opening down, in your mind you got a picture, okay, it's opening down, maximum. Okay. This one is opening up. So you're going to say that one is a minimum. So this means max. This is a min. Right. What is the vertex of this? Positive 1, positive 2. Remember, the minus is part of the formula right there. So it's positive. I mean, just think for a second. If instead of thinking of this like a vertex, you thought of it as a shift, the minus 1 inside would have told you to go 1 to the right. Right? That's why the H is positive. 1 to the right, up 2. So the vertex is 1, 2. Okay, now what do we mean by axis of symmetry? it's a line of symmetry. It goes right through the vertex. So if it's going through the point 1, 2, what is the equation of that line? Right? If this point is 1, 2, then the equation of a vertical line is always x equals a number. So what number must it equal? 1, right? It's going through the point that has x equals 1. So the axis is x equals 1. Right? That always matches up. Right? What's the vertex of this one? -3, 4. So vertex. Right? And then that would make the axis. Remember to say x equals. It's not a line if you don't have x equals in front of it. In fact, if you just said -3, for all I know, you mean y equals, and that's a horizontal line, not a vertical line. So make sure you include the x equals. Okay. Okay, so now we're getting into the factoring. And so much of this is about factoring, right? From here on out, it's about factoring. This was called simple quadratic because the a, meaning the coefficient of x squared, is 1. It's a one-step process, right? You have to think of the factors of 42 that add up to -13. So let's see, the factors of 42, are they going to be positive or negative? Right, since they're factors of +42, they're either both negative or both positive. Since they add up to a negative number, they're negative. So and then you got to let's think of the factors of 42. 42, 1 times 42, up 2 times 21, 3 times 14, 6 times 7. Which one of those, if I put minuses in front, add up to -13? Right there. So this factors as x minus 6 times x minus 7. Done. Remember, we're going to get to the one where a does not equal 1. And then once you've got those two numbers, you've got to split up the middle term and group the first two and group the last two. But you don't need to do that with this. Because a equals 1, you're done. Once you found those two numbers, you're done. Don't try to turn it into something more than it is. Greatest common factor, right? Now, you can get greatest common factor factoring with any number of terms, 2 or more. Right? You can't factor one term, but you can factor any number of terms, right? When you only have two terms, we've only got two ways to factor. It's either a difference of squares or it's a greatest common factor. Because all the rest of them, they have kind of trinomial as part of the name, 3 terms. Right? So this one is not a difference of squares. So it's greatest common factor. What is the greatest common factor between 3x squared and 33x? 3x, right? Both of those numbers are divisible by 3. And there's there's 2 x's as factors here, and there's 1 x as a factor here. So you take out one of the x's, and what's left? If you take away 3x from 3x squared, there's still an x there. And you take away 3x from 33x, there's still minus 11. Done. What's that? I mean, do you see where we got the 3x from? Do you see where we got the 3x? What? We just have to, if you take away the 3 and one of the x's from this term, what's left? One of the x's, right? I mean, really, the proper way to think of it is dividing. If you divide 3x squared by 3x, right, then the 3's cancel, and this x cancels with one of the x's, and all that's left is x. That's why you get that there. Same way with this. If I divide 33x by 3x, right? The 3 goes into 33 11 times, and the x's cancel. That's why it's 11. But we tend to think of it like if I take away, you know, what's left, things like that. It's really a divide in every case. So greatest common factor. These were quiz questions from the prior quiz. Factor a not simple quadratic trinomial, meaning that the a does not equal 1, and it doesn't, right? Then you got to go through these steps. Do you remember the steps? Two times 15 is 30. What are the factors of 30 that add up to negative 13? Are they both positive or both negative? They're both negative. Okay, so what are factors of 30 that add up to 13? Say again, Deshaun? Negative 3, negative 10. Right, negative 3, negative 10. Okay, so we found those numbers. What do we do with them? Take this negative 13x and write it like negative 3x minus 10x, because it's equal to that. And then we still have got our 2x squared and our 15. So we just use those numbers to split that up. Then what? Group the first two and group the last two. Right? There should be either a plus or a minus in between those parentheses. Okay. Now, what's left inside this side of parentheses? 10x minus 15, right? By introducing the parentheses, right, then that means that negative is going to affect that term also. We know that it was a plus 15. Negative times negative makes positive, so it's still a positive. Okay, now factor the first set of parentheses. What is the greatest common factor? X. And what's left inside the parentheses is 2x minus 3. Okay, what's the greatest common factor between 10x and 15? There's a 5. 2x minus 3, right? Is it a coincidence that there's the same thing in parentheses? No, it's supposed to be that way. You wouldn't be able to take the next step unless that was true. So if you got to this point and you didn't put the minus there, then you would have had 2x plus 3, and you would have had a mistake. And almost always that's the mistake. You didn't switch the sign. So usually that is the correct one. It needs to be what that one is. So just switch it so it looks like that. Okay, so now we've got 2x minus 3 will be one of our factors, and the other one is x minus 5. Right? So it takes, if you count it, 1, 2, 3, 4, 5 steps. It's always the hard one. Okay, perfect square trinomials. Remember, if it's a perfect square trinomial, you're going to be seeing numbers that are perfect squares, which you've got to recognize, like 81 and 49. Or even, on the first one here, there's a 1. Now, this was a quiz question that we had that, in fact, you probably, if you know the simple quadratic trinomial, you're just going to think of it like that, right? You're going to say, what are the factors of 81 that add up to 18? 9 and 9, right? So that is x plus 9 squared. X plus 9 times x plus 9. Okay, it's a little more apparent what we're doing when that's not a 1, right? But you could see that that's 7x in parentheses squared. And that's 9 squared. So your guess is that this thing could be, since that's a perfect square and that's a perfect square, it could be this whole thing is 7x plus 9 squared. And the only thing you got to check is the middle term. Is the middle term the correct middle term? Well, if you foiled 7x plus 9 times 7x plus 9, right? The middle term would have been when you got the 7x times 9, that's how many x's? 7 times 9 is 63. And then you'd get it again, 7x times 9. So there's another 63, which is 126. So it's correct. So this is the factoring. Remember, when you square a binomial like that, right, what you get is the first number squared, the first term squared is here, the second term squared is here, and then the middle is 2 times the first times the second. 2 times 7x times 9, right, which is 126. So if you just do that check, does it work? It works. Now, if you didn't recognize it, then you'd probably be trying to do that 49 times 81, whatever that is. What are the factors of that number that add up to that? It becomes a very hard problem at that point. This one, if you got, you probably would have factored it in any case without needing to go to special lengths. Okay, and then difference of squares. Again, you got to recognize when you've got a difference of squares in front of you. Do you recognize this as being a difference of squares? Right, it's a difference meaning it's a subtraction. That's written as a squared, so that's good. And then 9 is 3 squared, right? So how does a difference of squares factor? X plus 3 times x minus 3. Right. Remember, it's not x plus 9 times x minus 9. It's not x squared plus 3 times x squared minus 3. Right? It's x plus 3 times x minus 3. And you can confirm that by just FOIL it and see what you get. Right? The x times x is x squared. The x times negative 3 is negative 3x. And then this positive 3 times x is positive 3x. They cancel. There's no x terms, right? No x to the first. And then it's 3 times negative 3, negative 9. So just work a little backwards. Okay. Now, there could be combinations of things. Like, if you should always check something like this. If you just saw that as a not simple, then the numbers are getting pretty big. And you really kind of like to avoid having to factor something with numbers that big. But if you recognize, let's see, 3 is clearly a factor of both of those. Let's just check to see whether 3 divides evenly into 168, right? And you could do that in the calculator. 168 divided by 3, what do you get? 56, right? So this, if you factor a 3 from every term, then what you have in the parentheses is no longer one of those not simple. It's a simple. Now you just have a one-step process to go. What two numbers? The product is negative 56 and the sum is negative 1. The factors of negative 56 that add up to negative 1. Remember, if it's negative 56, that means one is positive and one is negative. Since the sum is negative, the bigger one is negative. Yeah, it's going to be 7 times negative 8. So plus 7 minus 8. So just there will be one where you got to do a greatest common factor, and then what's left can be factored a little bit more. And it's either going to be like that, or maybe it'd be a difference of squares. I don't even remember at this point. Okay, now we get into this was our first quiz question from the quiz that we did last time. Now we're solving equations by factoring. And it's kind of ironic that when we did the factoring quiz, everybody wanted to turn it into an equation and solve for x. And when we did the solve equation by factoring, everybody wanted to just factor and not solve for x. But remember, when it says solve, you're not done until you've got x equals a number at the end to say, this is what x equals. Now, what kind of factoring was this one? It's just simple, right? So that is x minus 4 times x plus 1 equals 0. So what does x equal? Yeah, remember, since you have a product equals 0, it means that one of the factors must be 0. That's the only way to make a 0 through multiplication. So that means that you could make two equations, right? X minus 4 equals 0, x plus 1 equals 0, and then solve each one of those, right? X equals 4, x equals negative 1. Solve it like that. Or if you recognize it at this point, just what number would I plug in there that would make this factor 0? 4 minus 4, 0. Negative 1 plus 1, 0. That's it. You know, there's a lot of, number one, not finally saying the values of x, or number two, trying to do that 5-step process to factor this when, in fact, it was a 1-step process. And the thing that happens is, when you try to do the 5-step process, in almost every case, you correctly picked the negative 4 times positive 1 to split up that middle term. You had the right numbers. And then you tried to go through the 5 steps and didn't get the right factors. But you already knew them at that step. Okay, the second one was a solve a greatest common factor factoring problem. What is the greatest common factor between 6x squared and negative 12x? Right, 6x. Okay, so if I factor as 6x from 6x squared, what's left? There's an x. Again, if you need to, you could go off to the side. 6x squared over 6x. The 6's cancel. One of the x's cancels. All that's left is an x. Okay, what's the next term in parentheses? Say again? It should have been minus 2. There was a whole lot of saying that was negative 6. Right? A lot of saying 6x times x minus 6. But remember, you should be able to go backwards, do distributive property, and get back to where you came from here. Right? 6x times negative 6 is not negative 12x. Right? That's negative 36x. So you definitely don't want to do this. So this is the factored form, equals 0. So what does x equal? From this factor here, what does x equal? There's the 2, right? We're almost always going to get that. Sometimes we miss this one. The x outside parentheses, what's the value of x that's going to be the solution? 0, right? When you don't see a plus something or a minus something, then 0 is the answer, right? Because a 0 in that spot would be 0 times anything is 0. So don't forget the x. Right? Okay, solve by factoring. This was the number 3 question. Okay, what kind of factoring? Say again? It's the difference of squares again, right? That's x squared minus 1 squared. So that factors as x plus 1 times x minus 1 equals 0. So what does x equal? Negative 1, positive 1. Okay, use quadratic formula to solve. What did we have to do to this one before we could do anything with it? Yeah, add the 4x. Okay, now when I add 4x to both sides, and it's going to show up on the left side, right? Where does it show up? It should be in the middle, right? It's the x to the first. So it should have been plus 4x plus 1 equals 0. So there are mistakes that you end up having a negative 4x, which shouldn't be negative, right? Because you added 4x to cancel a negative 4x, so it's an add of 4x here. Or you had the order of these things mixed around, which made you define A, B, and C incorrectly, right? What are the values of A, B, and C? 3, B is 4, C is 1, right? A is 3, B is 4, C is 1. So plug into the quadratic formula. X equals negative 4, which you'll be given the quadratic formula. 4 squared minus 4 times 3 times 1 divided by 2 times 3. Right? Just plug in. And if you have to solve on the test, there was a lot of on the quiz where somebody would show this, and then they clearly just put it in the calculator and got the right answers. That's fine. Okay, that's fine. If you put it in the calculator and get a wrong answer, and you didn't at least show me that you had everything correct about it, you just somehow made a mistake, then it's hard to give partial credit. But a lot did that. You could see they plugged in everything correctly, and then they did it. They gave me the answers that they had in the calculator by doing the same storing of A, B, and C, and then just do the quadratic formula, let it figure it out. So this one, when it simplifies, it's negative 4 plus or minus the square root of 16 minus 12 divided by 6. X equals negative 4 plus or minus the square root of 4 divided by 6, which is negative 4 plus or minus 2 over 6. Okay, so how do we deal with the plus or minus symbol? It's two different answers, right? There's one answer uses the plus and one that uses the minus. So this will be negative 4 plus 2 over 6 and negative 4 minus 2 over 6. Right, the negative 4 plus 2 is negative 2 over 6, which is negative 1/3. And the negative 4 minus 2 is negative 6 over 6, which is negative 1. Right, so that is on the study guide, it says use quadratic formula, which is given, to solve quadratic equations with real, like this, solutions or imaginary solutions. Okay, so what did we mean by imaginary solutions? Okay, what does I equal? I equals, we defined I. It's not negative 1. It's the square root of negative 1. Remember? That we needed to define I as the square root of negative 1 so we can deal with the square root of negative numbers, which sometimes happens in the quadratic formula. Right? So let's see, how do we deal with this in the quadratic formula? So I've got a quadratic equation. It will have imaginary solutions. The A is 4, the B is 1, the C is C is 5. So I go X equals negative 1 plus or minus the square root of 1 squared minus 4 times 5 divided by 2 times 4. X equals negative 1 plus or minus the square root of 1 minus 80 divided by 8. So you can see what's inside. It's going to be negative. It will be the square root negative 79. Now, 79, we can't simplify that as a square root. But we can simplify the square root of the negative part. How do we do that? The square root of negative 1 is I. So last step, negative 1 plus or minus I times the square root of 79 divided by 8. So again, we use that I to simplify something like that. The square root of a negative is I. Now the square root of 79, we just have to leave like it is. I believe that there's one question on the test. It's a multiple choice question that's going to have an answer like that. If you turned it all into a decimal, then you just need to turn this into a decimal and see what you get. Right? If you have the first term would have been negative 1 over 8. That's negative 0.125. That's easy to check. The next term, if it's got an I with it, check to see if the square root of 79 divided by 8 is the decimal that you got. That's how you match up your answers. Okay. So how many of you do feel comfortable to store A, B, and C and then use the quadratic formula that way? Not too many? A few? If you're going to do it that way, remember that you got to have your calculator in the right mode. Right? The mode key right here, it's got to be set on that line right there to A plus BI, or else it's just going to give you an error that says non-real. So make sure you set that to A plus BI, and then it'll give you an answer that involves I. And let's see. Evaluate the discriminant only and use the result to determine the number of real solutions to a quadratic equation. Again, this was the 5th question on the test. What do we mean by discriminant? Okay, discriminant is the b squared minus 4ac. It's what's inside the square root of the quadratic formula. It's not the square root or any other part of the quadratic formula. It's only that, right? So evaluating the discriminant just means plug in for A, B, and C and see what you get. So here's our A is 4, our B is -4, and our C is 1. Okay, let's plug that into the discriminant. B squared is -4 squared minus 4 times 4 times 1. Which is 16 minus 16, which is 0. Right? So how many solutions, how many real solutions do you expect when the discriminant equals 0? 1, right? Because remember, in the quadratic formula, here, if you're taking the square root of 0, the square root of 0 is 0. So when you add or subtract a 0, you get the same answer. That's why when you have the discriminant equals 0, 1 real answer, right? When the discriminant is less than 0, like -79, how many real answers? If it's less than 0, like on this one, it was -79, there was none. They both had I, they were imaginary, not real, right? And this one, it was equal to a positive number. How many real solutions did we get? 2. Right, those are the 3 possibilities. But don't do the whole quadratic formula. Make sure you're just doing the b squared minus 4ac part and getting a value. And then last, operations with complex numbers. Remember, what did we mean by tell me the relationship between complex numbers and real numbers. Which is the biggest set of numbers? Say again. Complex numbers are the big set, right? Complex are made up of all the real numbers plus all the imaginary numbers. It's kind of hard to read, but okay, the biggest set of numbers is complex, right? If there's an I in it, it's going to be imaginary. If there's not an I in it, it'll be real. And then you put all those together, those are called complex numbers. Okay, so how is it that we added or subtracted complex numbers? Nope. You add the real parts and you add the imaginary parts, right, for adding and subtracting. So that would be 1 plus 3 is 4. 2i plus 4i is 6i. Keep the real parts together, keep the imaginary parts together. If there's a subtract, you got to be a little more careful, which is 5 minus 7, negative 2. And negative 6i minus negative 8i, that's like negative 6i plus 8i. Okay. And then this would be the FOIL, right? When you multiply complex numbers, imaginary numbers, that's a FOIL. So that's 2 1 times 5i is negative 5i. 4i times 2 is 8i. And then what's 4i times negative 5i? Negative 20i squared, right? And then negative I squared equals negative 1, right? I squared equals negative 1. So that makes that a 2 minus 3i, or 2 plus 3i plus 20, right? Because this is, which is 22 plus 3i. Now remember, you could do that in the calculator. It's the easiest thing in the world. When you got problems like this, how do you do this in the calculator? Where do you find the I character? Yeah, go to the decimal point right there, right? Second decimal point. You can put these in the calculator. You don't even need to have it in the A plus BI mode, right? Just type it in exactly like you see it there. Use the I character that's on the decimal point, and you're going to get all three of those right. Okay. So those are all the groups of problems that we just went through. In the study guide, when I send it out, when it's posted online, it'll have the things up here that you're supposed to be getting out of that. Okay, it'll say that, you know, exactly what you're supposed to get out of that set of problems. So that